Welcome to Natural Habitat Adventures Daily Dose of Nature. I'm your host, Brooke Mitchell, and today's topic is polar adaptations, wildlife in a warming world, presented by NatHab Expedition Leader Maru Marcias. Thank you so much for being here today, Maru. Over to you.
Thank you very much, Brooke, and welcome all today to this amazing talk that we're gonna have. So let's just get right to it. I am very proud of being in this company because it thrives through the slogan of conservation through travel. And I am a biologist from Buenos Aires, Argentina. I have studied biology, science communication, and a master in marine science in Mexico. And throughout my years of research, I have been very close to conservation matters, especially regarding whales, southern right whales in Argentina, the whales in the Southern Ocean, aka Antarctica, and for the past 7 years with gray whales in Mexico, which took me to meeting this company and started guiding and being an expedition leader for the great gray whales of Baja. So, as always, this topic is very, very close to me and personal, of course. I've made a little roadmap, which we're not going to totally respect, but basically today what I want to say is what is climate change? Just a quick definition, but we're going to go deep into how climate change is affecting biodiversity, especially biodiversity in polar regions, and we're going to try to see what life strategies and the biology of these species helps or not helps to cope with these changes that we're having in this environmental crisis of climate change. And of course, at the end, we're going to try to debate as always and try to think of what we can do as individuals to help mitigate this problem. So let's get right to it. We are going to say that climate change is long-term shifts in temperatures and weather patterns. There are two key words here that we're going to keep repeating throughout the presentation. One is shift. It's not just global warming, it's not just increase in temperature, but what does that increase in temperature generate in the whole system of Earth? Remember that the Earth is all connected. So even though I'm not a climate expert, I have worked in the ocean, and the ocean is totally connected to our atmosphere. So we're going to see a little bit about that. And of course, the changes, the shifts are also generating changes in the weather patterns, right? And yes, we can say that in other times, in other geological times, there can be, there has been warmer climate that there is now because of sun activities or volcanic eruptions. But we are not going to argue that since the 1800s, the main reason for climate change, for the global warming, is human driven. It's because of our activity that the Earth's average temperature has just increased since the industrial revolution over and steadily, and it looks very little change, but actually a small change in temperature can have huge impact in the whole Earth system, right? And another thing is that it has been right now warmer than in the past 100,000 years. So this 1.5 degrees Celsius is, I think it's around 4 Fahrenheit. And because of that, we have the Sustainable Development Goals by United Nations that have a specific topic where the Intergovernmental Panel for Climate Change gathers the experts that are providing the scientific information, the technical information, and the socio-economic, how it affects particular communities and how can they mitigate. So since I have been studying biology, which is more than 15 years ago, this panel has gathered each year and it's more and more certain about the effects that this is having. And they even model different scenarios where if we continue the trend we have right now, something's going to happen. If we lower down, but to a very minimum, something else is going to happen. And so the different scenarios, depending on how much we act, this is all being modeled and it's the best known science for this. And I also wanted to show here that right right? The next sustainable development goal is life below water, and it's just a coincidence, but I like that these two are together because it shows the connection between climate and what happens underwater, which is what we are going to talk about. And for the skeptics, we can say that since industrial revolutions in the last 50 years or so, we have a 50% increase in carbon dioxide in the atmosphere. Um, so basically, the emissions that we have because of the coal and oil and the gas that is releasing, we have this. And if you check the atmosphere, this CO2, this carbon dioxide, has a chemical fingerprint that you can track down to its origin. So the origin is definitely human. It goes to the sector, it comes from the sectors of transport, industry, building, land use, agriculture, and energy. So it's definitely human driven. And even though it happened geologically before, it never happened at this rate, at this speed. And when it did happen, there was terrible consequences for life on Earth. So those are two things that we need to have in mind whenever we're talking about climate change. And of course, as I already mentioned, the global warming is not the only consequence. It's not only that we are having more temperature, but we are having extreme weather events like droughts. I don't know if I pronounce it correctly. Water scarcity, severe fires like the one in California that we cannot, yes, directly say, okay, it was because of climate change, but the climate change is generating the scenario of hot and dry that just sets the place for having these problems like fires, like droughts. Of course, with the increase in temperature, we also have the melting of the polar ice. Consequently, we have rising of the sea levels, floodings in the areas that are close to the coast, catastrophic storms, and all of these generates changes and decreases in biodiversity. And how does it affect biodiversity? Well, this is another thing that is very complex because we can classify it in different ways, but we're going to see through this presentation that is quite complex. There are direct effects of the rising of temperature that generate habitat loss and fragmentation, that generate changes in the breeding and migration patterns of some species. Then we have the effect on biodiversity when these extreme weather events happen, as we already said, storms and floods, droughts and wildfires. All the fauna that is in those places at the moment that these extreme weather events are happening is suffering from this and has consequences. And then we can also talk about species-specific impacts. The one that you probably most know is the one that is on the background in the picture is the polar bears that are having to move and are losing their habitat and are having to move faster to find the food because the ice is melting, and also coral reef bleaching, which is a species-specific impact, but can also have impact on the rest of the species that are associated with the corals. So we are talking about ecosystem level changes. This means that when one species is affected, there is a trophic cascade effect where the species that feeds on that or that has a refuge over there or that uses that particular species is just being affected, and it's just like a chain of effects, right? Especially this is going to happen in ecosystems where we have keystone species, as we will see in some examples, and the changes in the ocean, right? Ocean acidification, it just changes how the ocean has its chemicals and its nutrients and its regular cycles. So we will go through all of these through examples. Particularly, I hope that I chose some examples that you're not so familiar with, so that you can see how complex this matter of climate change is, right? Not just to think about 1.5 increase in temperature or in degrees Celsius, that for us maybe it's like, yes, I can cope with 1 more degree in the temperature, right? No. Okay, so we're gonna start with the gray whales, of course, because this is my favorite species and it's tightly linked to this topic. And we're going to start by saying that the gray whales are migratory species, like all of the baleen whales, but it's one of the species that has been most studied because it has a coastal migration. So we can follow her migration throughout. And we know that during the summer, she's feeding in the Bering and Chukchi Sea here in June, July, and August. And then it starts moving slowly southward to the Baja Peninsula, where we run our trips with Nahab, and it goes to its breeding grounds in the winter in lower latitudes, right? So something very interesting about this species and baleen whales in general is that the cost of energy to move to a lower latitude to do this huge migration is less than the cost of staying in talking about metabolic energy and coping with cold. It's more costly for them to stay in a place where actually they can't stay because the ice starts appearing right in the winter. But even if they could, it would be just too cold, and especially for the calves, the newborn calves need a warmer temperate waters more to the south to survive and to be able to gain fat to do the migration back. So this species is a wonderful marine mammal that is very linked to the temperature of the water, right? And so another interesting thing about this species is that 10 years ago, we were saying actually that climate change looked like it was helping the species. Why? Because they found some correlationships between the temperature and the amount of calf. The thing was that when we had less sea ice, the gray whales were able to feed for longer time in the Arctic, right? So that translated to more calves in the next winter. So in a way, it looked like, oh, okay, so there is less ice, there is more warm water, so the gray whales are being able to feed. And however, just recently, now we know that climate change is the very new and most pressing challenge for this particular species. And we're going to try to figure out what happened in the last 10 years that we scientists, researchers changed their mind about what was going on. And it's because it's complex and it's a delicate balance, right? So it's easy to think about it when we talk about the temperature that these whales prefer. And what we have is cold water or La Nina years, maybe, and El Nino or warm water. This map is showing the Baja lagoons, but the southernmost part. So when we have warm water, what happens is that would stay in the higher lagoons, in the more north lagoons like San Ignacio. And they won't go all the way south because to the south, the temperature is just a little bit too high for them. And comparatively, when we are in a cold year, this is the preferred temperature for the gray whales in their wintering grounds. So when we have a cold year like the one we had last year, because it preceded, it was after a La Nina event, sorry, El Nino, what we have is that they go all the way to the south and they stay longer in this part, in these south lagoons. So you can see how temperature is just changing the habitat use for the gray whales. And for them, there's no problem. They can just choose one of other lagoon, and it's not a real concern for the survival. But what about the whale watching companies that are in these lagoons? Depending on the year and depending on the temperature, they are going to have less whales and they're going to maybe struggle a little bit more to find the whales, right? However, this doesn't happen in San Ignacio because whether it is during their southbound migration or their northbound, they always pass by the middle lagoon, which is San Ignacio. Okay, so that is for the Baja lagoons. But what about what happens in the Arctic? So for that, we need to think about what these whales feed on. These whales feed on crustaceans, fish, and krill, and it's one of the only species that is benthic feeder. So she feeds in a very particular way that is suctioning the mud from the bottom. We're always going to talk about benthic communities, which is the communities that are here on the bottom. And she feeds mostly on these tube-dwelling amphipods, right? Most of her diet is composed of that. She can eat other stuff, and we will get to that, but mostly, or her preferred, is these tube-dwelling amphipods that are a type of crustaceans that make a tube in the sediment in the Arctic, right? So what happened with these two research that I showed? Why is everything changing? So by the time that the first publication was made, we still had this sea ice line, right? We still had a mean sea ice line that was around this area. But right now, because of warming world, because of climate change, we are losing the sea ice at a very fast rate, right? And you can see that the mean sea ice line that we have right now is very, very thin, and it's very, very low, and it's just continuing to decrease. So even though you have new areas, new ice-free areas where the whales can feed, well, this is kind of reaching a point where there is a threshold that has been passed, and the whole ecosystem, the communities that live in the Arctic, are struggling and are changing. So that's the food of the gray whale is changing. And this is better seen by this video. So here, in a normal ice condition in cold years, what you have is an ice sheet that during the spring is going to have sun reflecting on it, and is going to produce a lot of algae. And because you have the ice, you have a stable water column. So the algae thrives here and then just dies and goes all the way to the bottom to feed the amphipods. So that generates a very, very big community of amphipods. So by the time the whales arrive, they have so many fat amphipods that are feeding here, and she can feed on them like they normally do. But what happens in a warm year? In a warm year, the ice sheet has already melted. Gray whales arrive, and instead of having this algae that live their full life cycle under the ice and just die and sink off to the bottom, what happens is that these algae are now feeding the zooplankton, the water column, the animals that are in the water column, instead of the animals that are in the bottom. So we have less amphipods. And also, because of the loss of the ice, we have more movement of wind, and we have more mixing of the water. And this generates also that there is less sediment to generate the houses of these amphipods. So we are losing the benthic community in the Arctic, and we're having more zooplankton. And it's interesting because the gray whales can actually feed like planktonic. So are they adapting or not? Okay, spoiler, not so much. This has happened before, that we have a strong El Nino event that generates an unusual mortality event, and then the gray whales just kind of rebounds back. But what we see in the last few years is that they are not able to recover from this. They don't have enough food, and if they don't have enough food, they don't have enough calves. So we're seeing less and less calves. And even though we saw a rebound in 2024, this last year was very low and very concerning about the number of whales. So if you think about what we were saying about climate change, that it just generates more extreme events and more frequency of them, you can see here that the gray whale population is a pattern, but the unusual mortality event that we had in the 1920 and 2000 was a little bit shorter, and the one that we have now is longer, and it's taking them longer to recover. So is this going to happen more frequently and more intensively? Well, we still need to keep researching, because it's something that is happening at the same moment that we are studying it. But everything looks like it's going to be like that. It looks like there is a threshold that has been passed, where the ice in the Arctic is just retreating and retreating each year more, and is generating changes in the animals that the gray whales eat. And so, to think if the gray whale can survive this new problem, we need to think about the different families and the different strategies. So in biology, we have species that are generalists that can feed on multiple stuff, and we have some species that are specialists that throughout thousands of years of evolution and throughout many, many generations have specialized in a particular type of food, right? So we have three families in the whales, and we have what are the right whales that have truly specialized in skimming. They have these long balines, and they can only eat krill. You see this family here, and they can only eat krill because they're very, very specialized on going slow in the surface, skimming, right? On the contrary, we have a bit more generalist, we would say, with the humpbacks, the blue, the rorquals, which is this Balenopterid family, that can either lunge for catching herring, catching mackerels, catching different type of fish, or they can engulf and also eat krill. So depending on the food availability, they can kind of switch, right? Because they're not as specialized as the right whales, right? And regarding the gray whales, as I already showed you, there is a little bit of an adaptation. The gray whales have a very, very small balines. It's kind of like a primitive type of baleen that they have. Not necessarily that they are primitive, but it's definitely not so specialized as the right whales, right? And so she can kind of adapt. It's even easier for an example if we talk about, I don't know, hummingbirds and the beak that they have. You know, when you see a nice mangrove and there's a lot of species of birds and you're like, how are they not competing between each other? It's because they have such a different beak that they are specialized in a very specific type of food. But this has a consequence when we're talking about climate change. If you are too specialized and there is a change in your source of prey, then you're going to be in big trouble to adapt, right? Whereas if you are a little bit more omnivorous, like, I don't know, a bear or a raccoon, they can eat fruits, they can eat seeds, they can eat meat, they can kind of try to find the different food. So hopefully with that example, you can think about the whales and see how this can be a problem. So for the gray whales, there is a very interesting population that is called the Pacific Coastal Feeding Group. That is just 200 individuals that do not travel all the way back north. Even though we find them in Baja, when they are migrating, they don't reach the Bering Sea, they don't reach the Chukchi Sea. They just stay around this area that it's in the latitude around Seattle and Vancouver here, and they feed here on different things that they can find in the ocean basin here. And this Pacific Coast Feeding Group are actually smaller and have smaller skulls, actually. The only thing about this is that, of course, it's only 200 individuals that just decided, let's say, that don't migrate all the way north. And definitely, these particular whales are generalist feeders. They have been reported to feed on benthic amphipods, on mysids, crab larvae, ghost shrimps, herring roe, whatever they can find. And so their migration is a little bit shorter. So they don't spend that much energy migrating all the way to the Arctic like the population that we are always talking about. So this shows you a little bit of this plasticity, of this flexibility that the gray whales have for feeding. But of course, we're talking about a population that right now has 15,000 individuals. So this particular area is not big enough to feed all the whales. So all the whales cannot just choose not to migrate and choose to feed in this particular area. But as I show you in the video, they are trying to feed differently. They are trying to feed in the water column, but it's not as nutritious enough. And that's why we are losing the population. That's why we have less calves in these last years, because there is no way to sustain 25,000 population like we had before because of this change in their feeding grounds. Okay. Okay, so that's one of the examples of the changes in the migratory patterns, of the changes that are being produced by climate change to the gray whales. And right now we're going to head to the other pole. Now we're going to Antarctica, because in this place there is even a higher problem, not just for one species, but for the whole Antarctic food web. And it's because here we have a keystone species that could be affected by climate change, that is krill. So all of these animals are feeding on krill and are relying on just one single species, that is this 6 centimeter crustacean called Antarctic krill. And to put a little bit in context, the biomass, the total biomass of krill in the Antarctic waters is 380 million tons, which is just a lot. Wow, a lot. It's even more than the, like in number of individuals, is more than humans. But yes, the thing here is that more than half of this Antarctic krill is concentrated in the southwest Atlantic region, which is this green area that I'm showing you here. So this is Antarctica, and this is the area where more than half of the krill is concentrated. It's called Area 48. And you can see here that we included also the fisheries, because we're going to talk about a little bit the pressures that krill is having. So there are three key pressures on the krill population. First is the land and water predators. Birds feed on krill, fish feed on krill, penguins feed on krill, uh, and then the penguins are the food of the leopard seals. Then we have some seals that also feed on krill, and of course the baleen whales eat krill in the Antarctic and Southern Ocean. And we also have fisheries. There is a regulated fishery that catches only 620,000 tons of krill per year. And the problem that we're having is also that with climate change, remember I showed you that there was a very reduced area for more than half of the krill population. And with climate change, what we have is that this area is shrinking more and more. And climate change is also affecting the life cycle of krill because of the warming of the temperatures in the Southern Ocean. So we have these three main pressures on their populations. And Antarctica is a special place because it is very, very well regulated. But one of the problems is that most of the studies that were made to assess and to say which number of tons of krill was going to be fished was based on studies on land predators, because they're kind of easier to study. It's not that easy to know how many whales there are in the Southern Ocean. So there is a commission for the conservation of Antarctic marine living resources that regulates the fisheries through the study of the predators. And this is where I was lucky enough to participate in this project, because the idea was to see, okay, but probably the baleen whales are the ones that are the greatest consumer of krill in the Southern Ocean. And before we had, yes, the whaling, the time where they were catching whales meant that the gray whales are just now starting to recover. So when the populations are recovering, they are probably eating more and more each year because they are coming back, right? So this is all super interconnected. I told you that it was going to be complex. And so the idea was to try to tackle this question, right? And so for that, we use the help of tourism vessels, actually, like the ones from Limblad and other companies, that they allow the researchers to come in their trips and just count whales, as we were going to do the different landings that they do in the Antarctic Peninsula. The very good thing is that this is a systematic way of studying the baleen the baleen whales in the Southern Ocean. Here I am with a colleague, and the transects that we would design would be actually the same places that the tourism goes, right? So there is an overlap that allows us to use these tourism ships as platforms of opportunity and allow researchers like us to be able to do a very huge census throughout multiple deployments, throughout multiple trips and multiple years, to be able to count whales as we pass by. And of course, counting the whales, we need to do later. How would you say? It's this technique. What allows us is that when we are counting the whales in this transect, let's say that the ship is going and doing this transect, what we can do is that, okay, we counted the whales, and of course, if the whales were closer to the ship, the probability of finding these whales was higher than if they were at a more distance. So that allows us to generate a function of probability that we can then extrapolate. So if we find, I don't know, 20 whales, then in this small area, then we can extrapolate to how many whales there actually are in the whole area. So this technique allows us to make observations during the transit, during the ship going to the Antarctic Peninsula, and then make a wider study area. So it's quite interesting. Once you have that, you have the number of whales, and we have new research that shows us that the baleen whales are actually eating more than we thought about. They eat more tons of krill that we knew of. And with those two numbers, how many whales are there in the Southern Ocean and how much do they eat, then we can say how much they influence, how much krill do they need each year in this particular area, and deliver that number to the commission, to the CAMLAR, to be able to regulate better the fisheries. So what I'm saying here is that the numbers, the abundance of whales in the Southern Ocean was so out of date that probably the number that they were allowing the fisheries to catch is not reflective of how much really the ecosystem needs the krill, because we were not having in mind more whales each year, and they have a strong contribution to the amount of krill that we need. And so why is this important? Well, the whales are actually the true ocean gardeners. And there is an hypothesis actually that is telling us that maybe the recovery of whales is actually helping to have more krill in the ocean. Why is that? Because of their effect, that is this pump that we call. They have an effect that is, well, remember I talk about the land predators. I talk about the krill, and imagine that a penguin eats the krill and then it goes back to land and just poops on land. So the iron-rich feces that there should be in the ocean are staying on the land. But if you have whales that are eating, the whales are eating in the water column, and then they come to the surface. So they eat in depth, and then they come to the surface and they poop. And so they bring back these nutrients. These iron-rich whale feces are going into the surface, and this is what generates diatom bloom, which is actually the phytoplankton that the krill needs to feed. So it's a virtuous cycle where what they're eating is actually generating more and more food for the krill, and then it's generating more krill. So this is one of the things that can be totally affected by warming world, by climate change, because of this cycle, this chemical cycle that we have is so complex that if you remove either the krill or either the whales, because of the whaling that there was, you just change the whole ecosystem. And so putting pressure on this generates just a cascade effect where all of these animals are connected and need each other in this way. So we need to be very careful when humans are coming and saying, okay, oh, there's just so much krill that we can fish however we want. No, there is this precautionary principle that is, you need to really study what is happening here, so that you don't affect the ecosystem. And especially in a place like Antarctica, where just one species which is krill, is just so core and keystone for the whole system, where everyone relies on this species. Okay. Of course, not all of the changes are um, bad, let's say. They are only going to be shifts. Remember that I mentioned about shifts, changes, not just decreases, right? So in this study that I was able to participate, we actually found that the humpback whales were going more to the south than ever before. And this could be interpreted in several ways. One of the reasons could be that there are more eyes on the water because of citizen science, because we have tourism ships going, and because we have more research in the Southern Ocean. Then we have more eyes on the water that can detect these whales, right? But it looks like it could be because the global warming is affecting the ice and is generating new free ice-free areas. I always have trouble saying it in English, sorry. So newly ice-free areas that the whales can go and feed, right? Sort of like the same that we were talking about when we thought that gray whales were benefiting from less ice because they were accessing areas where in other times of the year they could not access because there was ice, right? And so in this study, in this small note that we did, we showed with a photograph of a guest and with a sighting that we had, we showed that humpbacks in the West Weathern Sea, West Weathern, sorry, Weddell Sea, the humpbacks were 150 kilometers more to the south than ever before. So it looks like they are expanding their range of use and habitat use. Um, However, as I mentioned, this is complex, so we need to think if these whales being there is affecting other species that do rely on the ice, like the minke whales. The minke whales do really need the ice to feed, and so what is happening with climate change is that maybe we're not having extinction of species in this particular case, but we are having a shift in the species. So some species are going to be benefited by this, and some species are going to be detrimental because of this. So as I said, it's kind of a tricky thing because one of them is going to be favored and others are going not to be favored by this increase in temperature and loss of ice. And okay, last example from the polar regions. I was going to put an example from my bachelor thesis, but a lot of emotions came, and I decided to put an example from a group that I work with during my bachelor thesis, but this is not my thesis. It's just that, okay, so we are in the Antarctic Peninsula. Again, we are in King George Island, and we have this cove that you see over here. Remember, I was talking about newly ice-free areas. So what happens if we have climate change, if we have global warming, and we have the glaciers that are melting year by year? Here you can see that in this place we have an Argentinian scientific base. They are collecting data on how the glacier is retreating and thus generating new areas that can be colonized by macroalgae, right? The algae that are in the underwater far out from the polar cove are now colonizing these shallow areas that you see here. And you can see here the years, and you can see how the glacier. And again, you can see that, of course, if the glacier retreats, I have this wonderful diagram that they put in this article that helped me explain these changes. So because of glacier retreat, we have substrate availability, and we have a nice macroalgal community. But again, complex because we are losing the glacier, there are some blocks of ice that can be broken down and can score the area suddenly. So in the places where they are more close to this retreat, we're going to have more ice scoring that is just, of course, affecting the community by scratching out all of the things that have settled down, right? And another thing is that if we have a glacier retreatment, we also have a lot of sediments that are going to the water and are generating turbidity. And algae need to do photosynthesis, and of course they need the sunlight. So if you have the sediment turbidity from the glacier itself, then that is going to impact negatively. So how is the going to settle? There is going to be, of course, again, a balance between species that can cope with the changes, that can cope with light turbidity, and that are going to establish and are going to colonize throughout time. So as far as they can be from the glacier, then you're going to have a more stable and more longer duration of a community. So this is, of course, again, very, very complex, but what we can definitely see here is that there is an expansion in the macroalgal communities due to the glacier retreat here in this particular area. Okay, and up, we are going to talk about to be starting to guide these seasons, and we are going from the polar regions and we're going to temperate regions to see how it affects. So the interesting about this, when I started guiding, I was like, okay, I'm more from marine environments. But when I started seeing what happens with the monarchs and their migration and their conservation, there is a lot of analogies and there is a lot of things that I kind of realized that were pretty similar to what I was studying with the whales, right? So again, we have an amazing insect that migrates, makes this wonderful migration like the whales do. And in this case, of course, the migration is triggered by the day length and by the temperature. So again, here we have, I think it's very familiar this from for most of the audience probably, because we have that the monarchs are all overwintering in the winter. We have them in Mexico, and then slowly they return back to the US and Canada in different generations. But when they come all together, just one generation, all of them here to this part of central Mexico. And how do they do that? Well, they kind of stop reproduction so that it triggers a metabolic saving of energy that allows them to do this magnificent migration, and they can live 5 times longer than the generations, right? Of course, as I mentioned, this comes from being sexually immature. So that means that they are going to roost here in Mexico, and then they're going to reproduce when spring comes back, right? So they're going to reproduce here, die off, and then the next generation is going to reproduce here, and then its daughters are the ones, the sons and daughters are the ones that are going to continue their way north in 4 or 5 generations. So as you can see, the timing is so important. And here we're going to talk about phenological changes. So if the timing and the day length and temperature is so important to this synchronized migration, then we know that there is going to be problems with a warming world, right? So they nest, they overwinter here in this Oyamel fir forest that we have in Michoacan and the Mexico state sanctuaries. And this place where they go has the perfect conditions for them to wait out. Again, they are waiting because there is the winter in United States and Canada, so it's very cold in the higher latitudes, so they go to these lower latitudes. Again, a little bit like the whales, right? And they are staying here in this Oyamel fir forests that are high up in elevation in a very specific place in Mexico, where we have what it's called the neovolcanic belt, which is a range of mountains that go from west to east, and that is just there and is actually a relic from a colder era. So that tells you a little bit about these specific conditions that they need to find of cold and humidity that allows them to stay there and to just kind of like pseudo hibernate. They are moving slowly, they're not totally hibernating, but they are there just resting and saving energy and waiting for the spring to come back again. And so how do we know how they are doing each year? Well, there is a combination of government and WWF doing census each year to see how the population is doing. But what they do is actually an estimate of the area that is covered in the forest by the monarchs, because you cannot really actually count them by one. But what you can count is the area that is covered, the area that is orange here to see. And of course, here we see that it has been doing the census, again, long-term patterns that help us understand the problems that they have. And you can see that there are some fluctuations, and that the general tendency, again, is of decrease, is that we are having a problem with the population. And there are two particular moments that I want to point out, because this one shows a big decrease. And then, well, in the last year, what we had is that we had good conditions, and we went from 2.2 acres to double. So what I want to point out here is that if you have good weather conditions and you have with good conditions that allow them to thrive, then they can quickly recover to double, right? They can double their population from one year to the other, and that is because they are insects. So we're going to go through that a little bit. But what happened here in 2002, we had a storm in the winter, that is this inclement and extreme climate and weather patterns that we can have in climate change, and that are going to affect the monarchs. The monarchs are very sensitive, and the combination of cold and wet is what frees the insects and generated an 80% decline in the population. And it also showed us that of the population, because when they actually saw all the monarchs there, they just realized that the biomass was much higher than previously thought. And this shows you that it's very important that these forests where they overwinter are protected and don't have any holes generated by logging one tree. Like if you cut down one tree, this ecosystem, this forest acts as an umbrella protecting from the weather to these monarchs. So if you put a hole in there, the air is just going to pass, the rain is just going to pass. And so just cutting down one big OML tree could have a devastating effect on the population. But what actually happened was that there was a human unexpected change for good, because after that storm, what happened is that there was a big flooding in the Angangeo town, in the population, and because of that, their government started to appear in more, the military started to appear in more, because they needed to help people rebuild their houses. And with that presence, the illegal logging stopped because there was more vigilance. So after this, we can say now that the illegal logging is no longer one of the major threats to the monarch population. We have at least a 96% reduction in illegal logging because of this extreme weather event that happened in 2002. And so again, what happens with this population, and what happens with climate change? These monarchs are insects. They need during their larva stage, they only feed on milkweed, and we have problems with milkweed because we're losing it because of land use change to agriculture, and 50% of the monarch live in the North Central American area. And so we need there is a combination of factors that need to happen and be synchronized. So if we change the temperatures, what is going to be at risk is the part of the population that does this migration. Because if you have warmer springs, then you're probably going to have less monarchs that are going to need to migrate. Remember that they are going away from the cold. So if you start having more and more temperature, then they might not migrate, and that can generate other problems. So definitely there is a big link between these whole factors, and considering that they move in a wide area, in a very very wide area, uh, the climate change can affect a lot, because in all of these places there can be problems, not just with these in the overwintering grounds, but also if you have, for example, rains when they're going back to their summer and spring grounds. And that takes me to this concept that I'm just going to say briefly, that what I was saying here is that there is different life strategies of species. Of course, the problem with the whales is that they are a large organism that has very few offspring, and that the timing of the maturation is late, and they have a long life expectancy, and they need a lot of time to generate this offspring. So if you have a problem or something that affects the offspring, then it's very difficult to go back from that, to recover. And as I mentioned with the monarchs, it's a little bit more, gives me a little bit more of hope what we saw from last year to this year, because if you generate the good conditions, if you protect the areas where they go, they can quickly recover because they have a lot of offspring. They can reproduce and have this boost of reproduction from one year to the other, and so the populations can thrive. But you need to have all the conditions for that to happen. But it's a little bit easier with the R strategies like the insects have than, of course, a big marine mammal like K strategy of life. Okay, so some takeaways from this is that climate change is real and is human driven, is generating changes, shifts in biodiversity, as I said several times. Some species can adapt, but only to a certain extent. So we should not just rely on that, because, as I mentioned, evolution takes a lot of years, and the speed at what we are doing here, generating, is not, it goes just too fast for species to truly adapt. And as we saw, the polar regions are the ones that are having most impacts and are most vulnerable to these changes in temperature because of the ice. And they actually allow us to study, help us to study climate change, because they act like kind of like natural laboratories where we can see what's going on in those regions is what is going to happen probably on a global scale. And because of that, with climate change, individual and collective action is urgent. And here we can discuss during the questions, what can we do about climate change? It's a subject that is so out of reach sometimes, and try to address it, right? But if it's hard, right? So here I have some suggestions. All of these suggestions, what try to say is that if the species are adapting, we should try to adapt too. We should, they are struggling, right? And we need to start thinking about our comfort and how much can we adjust so that all Earth is better. So here are a few things that we can do that mean to generate less carbon emissions. If you cannot do this, then you can actually offset your carbon emissions by, for example, traveling with companies that do that, like Natural Habitat. They pay some different NGOs, and they plant trees. And so this is a way for us to know the environmental footprint that we have, and then offset it with other actions, right? Thank you very much for your attention. I hope I didn't go all the way too far from the time. And I'm open for questions. This here is my email, my Instagram, and these are the trips that I'm going to give. So thank you again, and over to you, Brooke.
Well, Maru, I knew you were going to just give us so much information. All of your webinars are just packed with wonderful details, and you did it again. As all the hand clapping coming through, everyone agrees with me. Yes. And I will just throw it out there to everybody very quickly. If you would like to learn more about Antarctic whales, I actually had the privilege of bringing on Dr. Ari Friedlander, who runs the Friedlander Lab at UC Davis, UC Santa Cruz. I apologize. He is incredible. So definitely look that one up if you would like to learn more about that topic. It was a very interesting topic and webinar. He was a great speaker. So, but anyways, everybody, we
Yeah, I
have a few
remember.
minutes left with Maru. So if you have any questions, please plop them in there. We'll see how many we can get through, and then we will wrap it up for the day. So, could you explain a little bit further about what is humans' relationship to krill? Do are people eating it directly, or why are the fisheries in Antarctica? Why are they there?
Yeah, interesting. Yes, it's interesting because there wasn't that much of demand on krill before, but there is kind of like a marketing now because krill has this omega-3 compound that is used in supplementary diet pills. So there is an increase in demand in some particular countries, and also it's actually fished to use as food for pets and for the how do you say the cows and things and the farming industry. So it's kind of used like a supplementary or different dietary compound. So yes, actually, it's because of that that we are fishing krill. I know that it's not so well known, but definitely you can find that the demand is increasing, and yes, we are using it more and more each year. Mhm.
Yeah, I actually just today ordered a vegan, sustainably sourced omega-3 supplement. So, with made from algae. So, there are sustainable
Uh-huh.
omega-3. If anybody's into that, I'm very into fitness and health, and I am also a conservationist. So, there are a ton of krill
Mhm.
supplements out there, but I have found some really great vegan options for people who want to live sustainably, even whether or not you are vegan, just to not fuel that
Exactly.
industry and help save our whales and our krill. Okay, next we are getting a couple of not like sad questions, but kind of. What do you think is needed to get more
Mhm.
people on board with just climate change being real and making bigger shifts in industry and the way that our economies run in order to make a bigger impact and slow climate change?
Yeah. Yes. Well, I think the question here comes with the use of our time. What I try to put as a message is that the species are trying to adapt and species are struggling. And what we are doing is actually trying to be each time more and more comfortable, right? The technology and all of that is making us have things easier than before, right? So I think that what we need is more environmental education in schools and in general in the society, in the adults too, because we come from generations that we didn't have this so in mind. But just with environmental education, we can address the problem because I know that climate change can be a subject that just generates a lot of frustration and because it's so big and it looks like it's so unreachable, but it's not that so much because if we use a little bit of our day to read about it, to do some action like okay choosing to use a bike instead of using the car, to do carpooling. There are so many things that we as individuals can do to release less carbon dioxide into the atmosphere. And of course, we need to think about our politicians and the politics that there are, and how are they addressing, because it's not just the individuals, of course, it's a collective thing, that there are experts that are pushing the governments, that are pressing for these policies to be made, right? And we can act as citizens by voting correctly and by choosing governors that address the climate problem. Like there is no doubt right now that climate change is human driven. I didn't go into that because I know. I mean, it can take a lot of debate, but the scientific information is there. You can read about it. But of course, we as scientists need to communicate it each time better and better so that people have a way of accessing this information more easily and more trusty, right? So it's a thing that has just so many artists. I don't know if that it's a word in English, but so many things from where we can discuss. But definitely, what can help is that we as individuals take a little bit of our time to be a little bit more uncomfortable, to do things for the environment that actually are going to make us feel good after we do it. So it looks like it's choosing things that makes us uncomfortable, but in the end they are going to make us happy, because we are contributing to a better place for all, right?
Yeah, that was a perfect answer. And since we've reached the top of the hour, I will throw it back to you if you would like to add anything else to that very well said response before we head off today.
No, yes, thank you very much, everyone, for listening, and I hope I was made clear and that you learned something today. And I'm very happy to be always here to communicate these important matters. Thank you.
Yes, and thank you, Maru. Thank you for putting together another stellar scientific based presentation for us. I know I loved every second. And I would like to thank everybody who tuned in. Join us tomorrow for our next daily dose of nature. You can check out this week's lineup, including registration links, on our website at nathab.com/webinars. We did record today's presentation, and we will have the replay available on our website soon. With that, I will conclude the webinar. Goodbye, everybody.